everyone, welcome to the last day of the OWASP conference, and thanks for coming to this session. So I'm Stephen from Snyk. I'm based in Auckland. We've also got Tess in Wellington, but she can't join us today because she didn't quite get to the Malthouse for the COVID sort of breakout in Wellington conference last week, but she can't join us either. So as this is all about developers and the experience developers and the role developers play basically in securing our cloud native environments. So as developers, you now have the whole application declared in your code. It's all in your repo. So whether it's the open source libraries, the app codes, the platforms, the cloud, the containers, everything is now controlled from your repo. Including Kubernetes and the like. So without developers, there is no way to actually secure these things. So security organizations typically don't have the programming skills in order to go and fix all of the vulnerabilities. The only party that can really do this is the developers. So we really need a new approach to application security, and it needs to be a dev-first approach. So security still has a role to play. Security governs and measures the security outcomes sort of for the organisation, but it's the developer that has to fix the vulnerabilities that occur in today's sort of cloud native applications. Both of these parties need to come together to define the guardrails that are applicable for an organisation. So Snyk's all about promoting security and development working together so that you can find the vulnerabilities as early in the cycle as possible. And the reason this is so important is for every one AppSec sort of expert that there are in the world, there's about 80 developers, and it's never going to scale. In my last role, I spent a lot of time. I had 6 AppSec specialist people, 300 developers. We could just never get the development teams to adopt using basically the tooling to do this because it was just too difficult. So that's what we're about. So the goal really for Snyk is to help organisations to change the ownership model. So developers need to start taking on change and owning the whole security outcome sort of for the business. So it's not just about shift left. It's about changing from top to bottom and taking that ownership position. Now, this has typically been very, very difficult to do, and developers actually resist taking on that sort of ownership because the tooling, often from 10, 15 years ago, is not done in the way that modern developers want to work. So Snyk's all about the developer. We started it about 8 years ago, and unless developers actually adopt a different way of doing it, and they need to love using it, otherwise they just work around the problems. And how do you actually get that adoption? You build it as self-service, so there's low friction in actually getting hold of the service. You tightly integrate it with the repos and the tools that developers use sort of for doing their jobs sort of every day. You build a robust sort of CLI so it can tie into any of the pipelines and all that you want, and make sure it's simple and easy to use. But the most important thing is you've got to make it easy to actually fix vulnerabilities. And I'll show a little bit of that in a couple of screens because I've learnt from JP that the demo guides aren't sort of liking us in this room, so I've taken a few screenshots. So I'll show you what we mean by easy fix. The key thing is developers need to be able to fix problems without being deep AppSec specialists. And you can only do that by effectively curating and pulling fixes that are applicable rather than actually having the developer to go through an entire sort of learning cycle. So what does this mean in terms of what does a cloud native application mean in the modern context? So, and how does that relate to the OWASP type findings? So the typical place that we many organisations start is application code, that closed source code, the proprietary code that developers write. And how does that relate to the OWASP? So, broken access controls, you've got to be able to find those types of things, cryptographic failures or weak crypto, injection, all sorts of different types of injection, SQL injection, command injection, and some of the things, as well as sort of authentication failures, sort of data integrity, and server-side sort of forgery requests and the likes. All of these things you can find basically by looking in the proprietary code. So what does Snyk code do in this sort of space? We've reimagined a dev-first experience. The first thing we do is we make sure that when we find something, we provide a learning opportunity so that you can actually understand what is the implications of this. This is all built into the platform. You see this, the links to this learning right in your IDE. The other thing we do is the actual data flow of looking at how your code executes from source to sync, and we identify unsanitized sort of inputs sort of going through to where the data sort of ends up. We also give you an ability to go ignore, because this is completely irrelevant at the moment. So for the next 30 days, I'm not going to address this problem, make it go away. You can write that type of thing into your code and then come back to it at a later time, because you might be addressing some of those sanitization things at a framework level and you don't need to deal it direct in your code. So being able to ignore easily, but still create a audit trail is very important, so we do that as well. So what does it look like in your IDE? This is part of my demo. I've just pulled this from in this case, it's a Visual Studio. So right in Visual Studio, you've got a list of all of the vulnerabilities that are found. You press basically the button over here and go scan, or you can do it from your console just by doing Snyk test, and it'll pull all of that information up in your IDE. It'll show you exactly where in your code you're vulnerable, and here is our superpower. From all of the open source sort of repos and all around the world, we've looked at code and understand the context of what you're writing, and we've pulled together 3 example fixes for you right in the code. So that is a bit of a game changer, because now you don't have to read through the principles and the processes of how that works. We're presenting them for you. Quite often it might be, if it's a authentication issue, we might go use the bcrypt library and write it like this. So then you just add that to your manifest. You've now got the bcrypt library, and you're now actually doing authentication in a secure way. As soon as you've made that code change, you press test again, and you can see basically whether the vulnerability is gone, even before you commit it to your repo. So it's quite a change in experience. So getting down to the next part, 90% of what most modern sort of apps are built on is open source libraries. Which is a great thing until things like Log4j and all happens. So again, they address a number of the actual OWASP concerns. The thing we do here is we started with a large vulnerability research team that actually looks at all of the different sort of open source repos, and we calculate and compose that really complex sort of dependency tree of where the vulnerabilities are being sort of introduced. And we look for what is the most efficient path for getting rid of the vulnerability at the lowest risk of breaking the build. A lot of the tools out there will look at things like transitive dependencies, but they'll always say upgrade to latest, which introduces friction to your build pipeline, because you've got to go right through basically regression testing and the likes. So we always try and identify what's the minimal change using SEMVer technologies, looking at trying to find ways we can do it just with a patch rather than a major build, because quite often the schemas and APIs have changed when you're doing a major. So we make it available in a single click. And here's the second part of my demo. This is what fixing a open source vulnerability looks like in Snyk. And some people with really good eyes might go, that's not Snyk, that looks exactly like GitHub. And that's exactly the point, because we want the developers to be using the tools they're already using to fix vulnerabilities, not having to learn a Snyk interface. So we do this for GitHub, we do it for GitLab, we do it for Azure repos, we do it for all of the different popular repos and all out there. So you're using the tool that the developer already uses. So all you need to do to fix it is actually pull the merge request. Quite a leap of faith initially, because you want to make sure that what's being proposed is not going to break your build. So over time, you'll start by actually looking really deeply into doing this and doing really good sort of peer code reviews and go, are these guys going to break this? But over time, you'll probably find that we've actually done our homework, and a lot of cases basically you can just do the merge request and then it's solved. So with Log4j, we had these types of fixes already out within 24 hours, and 98% of our customers had solved deep down transitive Log4j instances in their environments within 48 hours. So it was actually pretty easy for them to do that right across the estates of all of the applications where they had access to source control. So the other thing we do is, and this is even further left of the IDE, is this thing called Snyk Advisor. So Snyk Advisor looks at all of these repos and actually gives you insight into vulnerable components that you might not want to use, components that are out of date, components that maybe their domains have actually expired and someone else has taken control of it and added malicious versions into the repo. These types of things. So we do this for open source libraries, but we also do it for containers. So it's about starting with a good solid foundation. We also look at the aspect in open source of being licensing compliant. So making sure that if you're building a commercial application that you haven't used basically versions of code like GL2 or something like that that might create basically legal risks and all for the organisation. We've also got the ability to look at bill of materials. So a lot of cyber insurance providers are now asking for a full bill of materials of what you're building before they'll actually provide insurance. Or if you can't provide it, your premiums go up, things like that. So the bill of materials is starting to be very, very important. So getting down to the next point, containers. So containers are also, your closed source code, your open source code is being composed into containers. Those containers actually come with their own risks. So we give you the ability to, not say, look at your current image here has got 200 and something odd. A lot of containers have about 1,000 or so vulnerabilities and all in them. So finding a better container to start with is always a really good thing to do. So we provide alternative upgrades that you might want to consider. So start basically with the slimmer, smaller containers. The advantage of slimmer, smaller containers is they start faster and all those types of things as well. And you should always look at actually what is the least amount of code and packages basically and make that the basis of your container. Then do your user layers on top of those. That's actually going to get you in a lot better posture. We also give you the ability to prioritize what you deal with in your containers sort of by criticals, highs, and all those types of things. So we're looking at not only the base image, but also the user layer. So the base image coming in from the Linux distro or whatever that you're doing, but the user layer, what's being layered on top. And we also give you the ability to look into the open source that you're bringing in the user layer. So rather than actually just a huge big list of all of the vulnerabilities you've got to look at, we give the ability to actually look at the open source that you're putting in and then picking basically that best based image. Already done that. With containers, we also provide the ability to fix, obviously, the open source sort of code that you're putting into the container and redoing that. So we're supporting custom images. So if you've got a base image, and then you might want to put your other user layers on it, and that might be the basis of maybe the auth or the crypto that your organisation need in a container. You can then actually publish that sort of into your container registry and say this version here is our kind of like our gold container image that we might want to use, and then when we give the actual upgrade sort of advice on which container to use, you can have your own image and all within your private registry being done. So rather than actually just always pointing people to the public, you can actually have your custom image being represented. We also work with other parties like our partners Sysdig. So containers with 1,000 basically vulnerabilities in them, really hard to actually go and fix all of those. But if you can break it down and prioritise to what are the open source sort of packages within that container that are actually executing in memory, you might only have 10 or 15. So then rather than dealing with 1,000, you're dealing with 10 or 15. And then you focus on, of those 10 or 15, which are the ones that are actually remotely exploitable, they have mature exploits, and which ones are trending and actually being attacked right now, and focus on maybe those one or two. So you're reducing the workload for developers down from 1,000 things you have to potentially deal with down to only a couple of things that really matter right now that might get in the way of actually releasing your build. So the last part basically of the iceberg is infrastructure as code. So infrastructure as code brings quite a number of extra risks and all with it. So over 2 million sort of Kubernetes sort of config files are publicly available on the GitHub things, and we find that a lot of them actually have things like shared secrets and all sorts of other things that just shouldn't be there. So we look at the Terraform, the Azure ARM templates, CloudFormation, and all the Docker Compose files, all of those types of things, and we look for configuration, insecure configuration vulnerabilities and all in those. The typical question that comes up when you're looking at infrastructure as code, the auditor will ask basically, which data assets are you actually exposing as this in this release, basically, and are any of those vulnerable? And the developer goes, well, I've written this YAML, but I'm not sure basically what this line and this line and this line do. I know about this part, but quite often the developer doesn't understand all of the different components within an IAC. Quite often they've been pulled from somewhere else, and you need a way to understand the context, because this YAML or Terraform defines and declares a whole lot of things about your application. How your container runs, the ingress to that container, what ports are open, what storage it's using, and is that internet facing? There's a whole lot of things that if you get it wrong, you've effectively put the organisation live on the internet, which is not a good thing. So as you're writing basically your IAC code in your IDE, you can do the same thing as before, test basically your code. You get the guidance basically again around, hey, you might want to actually put some ingress filters or egress filters and all on that, all those types of things. As you sort of commit it and merge it into your repo, we're constantly monitoring that. So if a new class of vulnerability comes out for configuration, maybe a certain crypto library used to be thought secure is now not, we're able to monitor those types of things, so you can see new and emerging sort of vulnerabilities sort of and all occurring. And then as you're executing your plans, in say Terraform plans for actually executing pushing stuff out, you can start putting gates and all in. So don't allow anything to go into prod that's got your secrets exposed, or that your connection to the database layer isn't properly sort of obscured. And the way we do these rules is against sort of industry best practice, like the assist benchmarks and the likes. And then we've applied those across all of the different key sort of cloud providers. Where we're moving next is what's called custom policies that are powered by the open policy agent. We work with a lot of the CNCF projects and all those types of things using the Rego language and the likes. there's just some examples basically of non-encrypted sort of S3 buckets, which are found actually still today quite commonly. And again, we're taking a kind of like a severity scoring sort of approach, so to focus you on the ones that sort of really matter. The thing we're doing next is quite interesting. We've acquired a company called Fugue, and the next thing we're doing is rolling out what's called policy as code using the Rego language. And that's a very fully featured capability that's available today already, and there's some very large companies already using it. So in terms of, it's now sort of moving Snyk's developer platform into the whole cloud security posture management. And what you're able to do at dev time is declare exactly how you want the cloud to be instantiated, and you're able to look at that in runtime as well and reconcile. So if something changes, somebody goes in via a console and makes changes, we can reconcile that drift back to policy and let developers know when something needs remediating. We also get to measure that against various sort of industry sort of vulnerability frameworks like NIST and SOC 2 and ISO and all of those types of things. And the other thing it does basically as we're discovering these things is it will give you a visualization of how your application is running in the cloud. So you'll be able to see from the front end through your load balancers and what are all of the other cloud services and all behind it that make up your organization. So you can actually visually see that. And we do that across Azure, we do that across AWS and also the GCP environments. So that's where we're going next. I can't actually put a date and all on that, but that's where we're going next. So sort of to summarise, sort of where cloud native apps sort of need to have a very holistic sort of approach to how you're managing the vulnerabilities, because they happen at all sorts of different places across your organisation. So Snyk's got a new approach to application security, and it is dev first. We're always focusing on the developer experience and focusing on actionability for the developers. And we think organisations really need to take a bit of a rethink about the tooling approach. The developer needs to have that self-service. It needs to natively integrate with the tool chains that you already use and not force you to use new interfaces. It has to have a very rich API to support full automation so that you don't have people intervention involved actually in your pipelines. And it has to be very much sort of embracing the community. So Snyk's security research people work with the Linux Foundation and OWASP and the CVE numbering people and all those types of things. You've got to be working basically in the community because we're all in this together. The integration needs to be unified. The developers shouldn't have to deal with the integration aspects, the data integration issues of multiple point tools from multiple generations of technology. But the most important thing is that the governance of this now needs to be collaborative, and it needs to be led by the developers rather than security dictating how this works. And I say this as an ex-CISO of a very large organisation in New Zealand. I was trying to actually get the developers to do this. If the developer's tooling and you're introducing friction to the life cycle is not fit for purpose, people will not adopt it and you will not be able to do this. So it's a very collaborative approach you need, and developers are the key to make it happen. So thanks very much for coming along today. If there's any sort of questions, I'm willing to sort of take those now. Does anyone have any questions? No?
when you first sell this to an organization, what's their experience like? Because I assume that when you first implement this tooling, you probably get a lot of vulnerabilities or
Yeah.
red, where I say, and how do you guide your customers through that?
So the whole thing with the approach about, you know, how do you start this without overwhelming a development environment or organisation is really important. You don't need to address all of the 4 layers at once. You can start with what makes the most sense for you. What's going to materially reduce basically the risk. The next thing is we typically recommend a stop the bleeding approach. So we might get a view of, hey, you've got all these hundreds of vulnerabilities, but maybe just how about we stop actually new critical ones coming into the organisation. So start just with that. So you can take that step-by-step sort of incremental approach. Once you start getting on top of the new stopping the new vulnerabilities being added, then you start doing things like sprints that will actually address the backlog, effectively the security technical debt. So you can take that sort of incremental approach. And you need to obviously be partnering with the security organisation to show that you are making meaningful progress. Because there's a lot of organisations that will do pen tests, but then because the developers aren't empowered to fix the problems, nothing changes from test to test to test, year to year to year. We're about empowering the developers to actually make that incremental change so that over time your security posture is in a lot better place. Thanks.
So yeah, I'm guessing you get quite a lot of CVs that get released, and all of a sudden now you have this influx of people that have vulnerabilities. But I'm more interested in the source code review. So when, say, a big company has a large amount of source code, and it's not just simply they've got this old library that's now outdated, how do you really analyze that? Is there some sort of I guess, common like input-output type stuff where you go, okay, this is not being sanitized, or is it more of a larger scale analysis?
Yep, probably a couple of different things there. In terms of scanning your code, things that go into the repo becomes the key source to that. So we're looking at giving you indications of things coming into the repo, so you can stop bad stuff going into your repo, but we're also monitoring the repo on an ongoing basis. So if there are new vulnerabilities that occur that weren't there at the time that you originally committed them, we're going to pick those types of things and all up. So I might have missed the gist of it, but yeah, cool. And we do that sort of at open source, so we also do it at the proprietary code sort of level and the containers and all as well. So you've got that constant monitoring, because a lot of people have got, deprecated packages that deprecated 10, 15 years ago, and no developer even knows how to code in that language anymore. So sometimes you actually can't fix it, and then you need to use different controls. You might need to use a control like at a WAF layer or something to stop people doing a particular type of a technique. So Snyk, whilst we focus on dev time, there are still partners like Sysdig that needs to do the runtime stuff, and you still need to take that defense in depth approach. Yeah. Cool.
Any final questions?
No, all good.
All right, thank you very much.
Thank you.